Good morning. You can call me GM Rosas. I've been a radio access network specialist for almost 18 years, 17 plus years. Kung titingnan nyo, I've been with the traditional RAN for a decade now. And katulad nyo, for me, Open RAN is a new thing, and is actually a welcoming development for the industry. And for although na-discuss na rin to, what is Open RAN in the previous session in the morning, I think may mga bagong pasok, and I think we have to highlight some points to define what is Open RAN. The main question now is, what is Open RAN? And before we go into the details, okay, so we have to have a discussion on the key challenges a telco operator or the telco operators face now. So we have identified three things that they are facing. First is the faster time to market. So ito yung kumbaga at the end of the day, a telco operator is a business, and in a neoliberal market, kailangan ang end goal natin is kumita. So, and one way for it is to invest in infrastructure, and kailangan mong maging mabilis to deploy your assets na magbibigay sa'yo ng revenues. And yan yung unang-unang tinitingnan ng mga operators. Gaano ako kabilis makapag-roll out ng assets, ng features, ng services. And it entails a lot for a significant investment para sa new network. And it should be also flexible. Although you can schedule it ahead of years ahead of time, but at the end of the day, you have to think gaano kabilis ako makapag-roll out para makapagbigay agad ako ng service at para kumita agad ako. Syempre, yung agad ang titingnan nila. Second is, of course, if you have rolled out already the infrastructure, you have also to check every day the performance. Kasi even una mo kasing sa isang business, kailangan muna ng entry. So pag bago ka sa business, you have to entice consumers. You have to get the subscribers. So like a use case for this is sa Pilipinas. You have the duopoly before. You have the Smart and you have the Globe. And then biglang pumasok si Dito. So for them, napag-aralan nila, gaano pa tayo kabilis mag-roll out. Lalo na noong time na nag-bid for the spectrum, pinag-aaralan na nila yan. Pag ba tayo na-approve, how fast can we deploy? And at that time, I think the ICT or NTC have, meron sila contract or meron silang bond to tell the new entrant gaano kayo kabilis. You have to roll out this fast, or meron kayong deadline na kailangan operational kayo by this day. So, yun yung hinahabol nila. So, kaya yun ang titingnan ngayon ng operator. How fast can we roll out? And then, syempre, pagka-roll out, may infrastructure ka na, nagkaroon ka na ng mga, through marketing, through the business people, nagkaroon ka na ng subscriber, nagkaroon ka na ng subscriber base. You have to check the performance and to improve it para ma-retain mo yung mga subscribers. And the key performance indicators would point you to three basic things. First is the coverage. So, better performance means better coverage. So, dapat wala ka, yung tinatawag nila na dead spot. So, for example, in your area, kunyari pumunta ka ng probinsya, una mong tinitingnan is coverage. And for layman, or for laymen, para one way to check the coverage is the signal bar. Siyempre, if you have the phones, you check at the upper right and check yung gaano, ilang bars ba ako? Meron ba akong 4? Meron ba akong 5? Okay? So, may mga tao na medyo OC, ayaw nila nababawasan yung bar na yun. And yun lang naman yung way to check the coverage. And for some technical people or for some enthusiasts, not necessarily into telecommunications, you download applications like GNetTrack to check the DBM levels. So medyo precise na yon na I have only 96 dBm or I only have 100 dBm. Or meron akong 69 dBm, ang lakas ng signal ko. So those are the indicators for people to check if there is coverage. Pero for radio access network specialists, you have other indicators also. You have the drive test, you have the tools to check better coverage. You have the timing advance to check how far you're going. And then, syempre, okay, may coverage ako, may signal ako, but how's the quality? So you have to enhance also the QoS or the quality of service. Paano mo makukuha yun? Is through optimizing several things like the physical layers, yung antenna. When you say physical layers, you have to check the antenna kung tama ba ang installation, kung tama ba ang sipat niya, kung tama ba yung tilting niya, yung azimuth niya. So, and then you have the features, you have the parameters, you have a lot of things going on at the back office to enhance the quality of service. But basically, ano ba yung quality of service? Para sa ating mga tao, so tao rin naman yung mga nasa telco. I mean, for us laymen, quality of service means the call, the text, the SMSs, or the data. Okay? So sa mga lumang tao, naabutan pa na call and text lang, masaya na nun. Okay? So nakakatawa ka ng maayos, naririnig mo sila, masaya ka, nakaka-text ka pag Pasko. Uso nun yung DM, di ba? Isesend mo sa December 24 para umabot ng December 25 kung naabutan nyo pa na puro Nokia lang yung phone. But now, medyo demanding ng mga tao kasi people are doing FB Live, doing TikTok, inis na pagbabagal. So medyo tumataas na yung requirement. So you have to have check throughput. You now have latency. Okay? So throughput, mga tao ngayon marunong na, dina-download na nila yung Ookla, dina-download na nila yung Open Signal to check yung throughput. Ano ba ako? Medyo aware na rin yung mga tao unlike before, like in the early 2000s, 2010s, na mga tao hindi alam to, pero now alam na nila na magrereklamo na sila, below 100 Mbps lang ako, hindi ito yung binabayaran ko, parang gano'n, di ba? And then for the latency, so sa mga naglalaro, pinapakahalaga. I mean, for normal na tao, hindi naman normal. Mahirap lang maglagay ng mga labels. Pero anyway, sa majority ng mga tao, they look at the throughput kasi mahilig tayo mag-download ng mga bagay. Lalo na ngayon, remote learning. So we download materials and you have to look at the bandwidth and you have to look at the throughput kung gaano ko kabilis mada-download. Dahil for those people na naabutan pa yung mga Infocom days, wherein you have DSL, you have like 300 kbps bandwidth. Masaya ka na makaabot ka ng 300 kbps but at time, magda-download ka ng like 1 MB na material for iiwan mo siya sa gabi, pagising mo, naka-download na. Masaya na mga tao noon. But now, you have to download material, a PowerPoint presentation, an exam, or a video, pictures, in a matter of minutes. So, mag-download ka lang ng lalagpas 15 minutes, naiinis na mga bata ngayon. So, you have to check the bandwidth, you have to check the throughput. And for gamers, hindi lang basta-basta kailangan yung throughput. You have to have faster latency. Okay? You have to have faster response. Dahil patay ka na pala, pindot ko pa na pindot, patay ka na pala. Because the latency is not that good. So, may inis ka rin. And it's not a good experience. Better performance actually at the end of the day also, at the point of view of the consumer, is experience. Okay? Masaya ka ba? Nakakalaro ka ba ng maayos? Okay? Nakakapag-download ka ba ng maayos? Nakakapag-stream ka ba ng maayos ng mga K-drama? Okay? Na ayaw mo siya na natitigil, ayaw mo siya na nakanganga, tapos hindi gumagalaw. So that's better performance, means better customer experience. And we enhance the quality of service by also expanding capacity. Dahil sometimes the quality of service is pumapangit because ang dami-dami nyo na gumagamit for a single cell. And radio access network specialists or people in the telecommunication network are planning this capacity. Pag nakikita nila naman, okay, ito na yung consumption ng mga tao in this area. So we have to expand, we have to upgrade. So after mo mag-deploy, makapag-roll out, nandiyan na infrastructure, then you have to optimize. You have to better the performance. But the third key challenge would be at a lower cost. Siyempre, it is a business. So you have to have revenue. And to achieve revenue is to have lower cost. And how do you achieve that? So maraming bagay na pwedeng gawin. So hindi lang tong nandito sa PowerPoint. But i-highlight lang natin. For example, you can cut energy consumption dahil ang mahal ng kuryente sa Pilipinas. So you have to cut expenses in terms of the energy consumption. And telco vendors now offer features wherein you can have power savings. Okay? Itatawag nila na power saving features na not all the time an equipment can use this. They don't have to use this power this kind of power level, power consumption. Sorry. At this time, for example, if meron kang idle time, pwede nilang i-schedule yan. So at the end of the day, meron kang savings sa kuryente. And then another one can be a lower equipment cost so that you can reduce the CAPEX and OPEX. CAPEX means the capital expenditure. Ito yung mga major purchases na ginagawa ng company for a long term. So ito yung mga schedule, ito yung pinag-uusapan ng board. Na ano ba, bibili ba tayo ng ganitong kadami? Ito ba ang technology natin ngayon? Magsha-shutdown pa tayo ng ganito? Mga ganun. So, pinag-uusapan yan para ma-schedule yung gagastusin. Kung may ganito pa tayong kadaming pera, kung ilan pa yung uutangin natin, okay, para sa CAPEX natin. And then you have the OPEX or the operating expenses. Ito yung mga day-to-day na expenses. So ito yung on top pa ng CAPEX. So bumili ka ng assets, ito yung babalik tayo sa faster time to market. Ito yung nag-roll out. So before roll out, nag-schedule ka ng CAPEX mo, ito yung number of sites na ilalagay mo, ito yung dami ng equipment na bibili natin. And then you have the OPEX ng operational ka na. So marami ka may incur, na-schedule din yan, but sometimes medyo pwede siyang tumaas, so nakakabawas siya sa revenue. So ito yung mga challenges ng telco operators, yung pag-roll out, pag-maintain ng network at lower cost. So let's go to if we are to discuss Open RAN, well, let's look back, okay? And let's first look at how other networks are built now. So we go back to the current traditional RAN. Ito yung tinarabaho ko for the past years. And to give you an idea, I think it was shared also by Sir Herbert a while ago in the previous session. Yung market share as of 2021. Hindi ko alam yung data niya kanina, but for this one, for this slide, is you have the data for the first quarter of 2021. And you can see that mabibilang mo lang sa mga kamay mo yung major players, major vendors, or major providers para sa ating mga operators. You have Huawei, you have Ericsson, you have Nokia, you have ZTE, and then you have Samsung. Sasabihin nyo, Samsung ba may network din? Yes, they have. And if I'm not mistaken, they have this 3% share, and maybe most probably these are more on the East Asia part or pag pumunta ka ng North Korea, you'll see some Samsung network there. But yes, they have. But give you a history, decades before, they can only see Nokia and Ericsson leading the space. I mean, in the Philippines, before, you'll see a network operator would have service areas na Nokia, at then you have service areas na merong Ericsson. And during that time, in my opinion, the vendors dictates everything. Parang sila yung hari nun. Na pag sinabi nila, okay, ito ang gagawin natin, the network operators would listen. But, syempre, in any market or in any industry, there will be disruption. And disruption comes kapag may pumasok na bagong player. And that's Huawei. Pumasok sila, I think, in the early 2000, pumapasok na sila. And maliit lang sila noon. And then they started to expand. And then now, you look, they have 29% of the share. But regardless of this history, for the past decades, you will only see a few players. So ito, at 2021, ito yung mga major players natin. And as we look into the traditional RAN, reviewin uli natin. I think this was discussed a while ago. But sige, tingnan natin kasi I'm assuming that most of us as are ECEs, so you will have a better understanding of this. So let's break down the elements of the mobile access or the radio access network. So pag makakita kayo ng mga cell sites, syempre makita mo yung towers. Sa malayuan, tower siya. But if you look closely, you'll see three major elements. And the first one is the antenna. So the antenna transmits the radio signal to and receives signals back from the user equipment. Okay, communications 101, antenna. What is an antenna? Antenna is a device. And what kind of device? It is a passive device. Passive device, COMS 101. Ito yung mga device na nag-work without an external power. So, hindi mo kailangang isaksak ang antenna sa kuryente para gumana. So, it's much like a transducer or any yun yung mga device na nagka-translate ng physical domain to the electrical domain, right? So, you have the antenna, ito yung usually nasa taas. Ito yung mga pinapaling mo sa service area. Okay? So, it has gain. Ano yung gain? So, if you go back to our communications theory, ito yung gaano ka-directional lang isang antenna, gaano yung kanyang footprint, kung gaano siya kalayo pwede niyang marating, at kung ano yung kanyang sinusupport na band. So, and to give you a refresher, so ang antenna, since it's directional, you can compare it to an what do you call this? Flashlight. So kung saan mo nakatutok yung intensity, yung lumens niya, kung saan mo siya tinutok, dun magko-concentrate yung ilaw. So much like a flashlight, antenna ganun din. So makikita mo sa mga antenna, sa mga towers, it's three-sectored antenna to mimic a cell. Okay, a hexagonal cell. So if you go back to your COMS 101, kaya nga siya tinawag na cellular technology or a cellular wireless technology is because the parang a basic area niya is a cell. And you can mimic that by having three sectors if you'll go back to your coordinate system, magkakaroon ka ng quadrant 1, quadrant 2, quadrant 3, quadrant 4. Doon iikot ngayon yung tatlo. And most probably an antenna would have like a horizontal beam width of 65 degrees. So mabubuo niya yung buong 360 if you have a three antenna site. So meron kang sector 1, you have sector 2, and then yung sector 3. Yun yung if I think most of you or some of you are working in the telecommunication industry, in the subcon. So you have an idea. So pag kunyari may problema sa area dito, at walang signal or pangit ang performance, unang tinitingnan is the layer 1, and that's the physical layer. And antenna is part of that. So, unang titingnan, may nakaharang ba sa antenna? Okay? Yung antenna mo ba maayos ang pagkakakabit? Or yung antenna mo ba nakatungo o nakatihaya? Okay? So, kasi para siyang flashlight, so you have to check the physical layer, and that's the antenna. So, yun. Medyo napahaba. Anyway, and then the second element would be the radio unit. So, it performs the radio functions, including frequency conversion and amplification. So, balik ulit tayo. Comms 101. Amplifier. So, yun yung basic unit nito. So, ito yung nag-filter, ito yung nag-convert ng frequency, ito yung nag-modulate, ito yung nagbibigay ng radio function para sa, ito yung nag-feed ngayon sa antenna. So from antenna, going to the radio unit, so pag nagtatransmit ka, radio unit, siya yung lahat ng mga conversion, lahat ng amplification, siya yung nagpa-process, and it feeds to the antenna, and the antenna, binubuga niya. Okay? And then it receives, kasi may transmit, receive, di ba? Comms 101. Transmit, receive. Receive naman to the antenna. And then the antenna translate it from the physical domain to the electrical domain, send it to the radio unit. So, makikita nyo dito, ito yung radio unit. Nasaan ba yung ano natin dito? Pointer. Okay? Pointer. Yan. So, ito yung antenna. Isipin nyo na lang, kunyari, antenna yan. So, basta ito yung mga puti. Dito sa mga hindi familiar, punta kayo pag nakakita kayo ng cell site sa rooftop or isang self-support tower, tingin nyo nasa dulo yung puti, yun yung antenna, yung square na yun. So may mga antenna na pwede kasya ka, may mga antenna ngayon lumiliit na. So may mga MIMO, so that would be out of scope, but yeah, so iba-iba ang sizes. So basically ito yung nasa taas. It supports the 2G, 3G, 4G, 5G. So actually, if you say these two different radio access technology, iba-iba yung spectrum niya. Kasi let's go back again to Comms 101, the electromagnetic spectrum. So, di ba? Pag babalikan natin yan, you have the visible spectrum, you have the infrared, you have the ultraviolet spectrum. So, yung radio frequencies would be somewhere below the infrared. Okay? And then the radio frequencies, mahati pa yan from the power line, going to the AM radio, then TV, and then you have the mobile cellular network doon in somewhere there, okay, between the TV and the microwave oven or the microwave spectrum. So nandun yung mobile, nandun yung cellular technology, and ngayon hahati-hatiin pa yon, and it was or it is assigned to different technologies like 2G. Although 2G, we're expecting it in its twilight. I mean, medyo marami ng countries na nag-shutdown nito, also for the 3G. But for the Philippines, we still have this. You have the 2G, 3G, 4G, and 5G. Well, some operators are thinking of shutting down some of them, but okay, but basically we have these technologies pa rin. And the antenna supports this. Some antennas, some technologies share the same antenna. So, and that would be a different scope pa rin, but at least to give you an idea. So, makikita natin dito, ito yung connection, the radio unit is, for now, as of now, the current implementation is the radio unit or the RRU, or sometimes they call it remote radio head, remote radio unit. So, malapit siya sa antenna. So, nung unang, hindi naman unang panahon, pero mga somewhere, long ago, the radio unit sometimes, noon nasa baba pa ito nun Okay? Then, papadala mo sa antenna ng mga 2G pa. But now, the design was that the radio unit nasa taas na. So, para mas efficient, para walang masyadong loss. Kasi, balik ulit tayo sa comms natin, electronics, habang humahaba yung cable natin, we introduce loss. So it's a way for us to lessen the loss from the radio unit to the antenna. And then the third element would be the baseband unit, responsible for managing the capacity within the cell. It's basically a computer. Okay, it's a processing unit. na lahat ng mga functions, lahat ng mga decisions would be processed on the baseband unit, usually in the cabinet below. And these are connected by the CPRI, or the Common Public Radio Interface. It's usually a fiber. Okay, so it's a interface, okay, na sinusunod ng lahat. So the question now is, okay, so ano ngayon? May antenna, may radio unit, may baseband unit. So in a traditional RAN, this, except for the antenna, ha, kasi antenna can be a different vendor. You can mix and match. You have CommScope, you have Katrain, ano pa ba? Basta yung may mga antenna. Huawei has its own antenna. So, but the front haul down the radio unit down to the baseband unit, this is a closed front haul with a single vendor. Isa lang to. You cannot mix and match. I mean, let's go back to the CAPEX. Pag nagplano ang network, okay, gagawa ako ng site. Gagawa ako ng 1,000 sites. So anong vendor ang gagawin natin? So, syempre magpapasa ng mga vendors ng mga proposals nila. And on those proposals is the design of the site. And yung design ng site na yun would be under a single vendor. Hindi siya pwedeng bibili ako nito sa Ericsson, bibili ako nito sa Nokia. Bakit hindi pwede? Dahil malolurky yung network. Magugulo. Tapos isa pang problema niya, magsisisihan din yung mga vendors na hindi kasalanan ng radio unit mo yan, hindi kasalanan ng baseband unit mo yan. And I think hindi lang din sisisihan. Walang nag-try nito dahil sino ba namang sira na magdi-design, okay, gawin natin chop suey hoto tayo, tapos hindi gumana. Tapos, edi sayang yung capex mo, di ba? So, the design, it's safe to design a network that is closed for a single vendor kasi yung interoperability niya. So, for sure, pag binili mo sa isang vendor itong radio unit mo and baseband unit or yung BBU mo, isang vendor, gagana siya agad. Okay? So, yeah, situation today. Current RAN implementation offered by incumbent vendors combine the equipment in an inseparably linked set of proprietary hardware and software components. So, I like to highlight this. Inseparably linked set of proprietary. So, this is a keyword. Proprietary. Anong ibig sabihin yan? Secret, ganun. So, pag sinabi ng Nokia, ano yan? Secret, kami lang nakakaalam ito. Pag sabi ng Ericsson, okay, secret, amin lang din to. So, yun yung sinatawag natin na proprietary. Ilabas mo yan, kulong ka. Di ba? So, trade secrets, kumbaga. So, pag sinabi mo, kami lang nakakaalam nito. So, pag bumili ka sa amin, package deal. You have the radio unit, you have the baseband unit. Okay? So, and then you have to also consider that it's proprietary hardware and software. So, alam mo yun, kumikitang pangkabuhayan talaga. Kasi parang, bumili ka sa amin ng hardware, sa amin din ang software. Hindi ka pwedeng, bumili ka, okay, Nokia, bibili akong Nokia pero software ko Ericsson. Okay? So, hindi yun pwede. Kasi nga, malulurky ang network pag ganun. So, talaga inseparably linked. Pag bumili ka nito, isa lang talaga, isang vendor. So, from the start of the planning, pag sinabi mo na, okay, kukunin namin ang Nokia, yun na. Magha-happy-happy na si Nokia dahil alam nila sa kanila lang bibili lahat. Software, hardware, and even the service. You know why? Because since these are proprietary, ang hirap talaga i-pronounce ito, no? Paano ba Tagalog ito? Basta, yun. Proprietary is meaning, kayo lang hindi nakakaalam. Okay? Pag sinabi mo, okay, katulad namin, we are a radio access network specialist. Pero may subset pa yan. Ano ka ba? Nokia ka ba? Ano ka ba? Ericsson ka ba? Huawei ka ba? Okay? So, kunyari, nagtrabaho ako for 3 years in Nokia. So, pag nagharap uli ako ng trabaho, ang pang-highlight ko, Nokia ako. Okay? give you my experience before. When I started with Globe before as a cadet engineer, I was in a Nokia environment and an ecosystem Nokia. So parang ginalingan ko, inaral ko ang Nokia. Then I tried to explore it outside. And ang nakuha kong project is Ericsson. So I have knowledge on Ericsson kasi may Ericsson network din noon, but hindi ako tutok doon. Kasi sino ba naman ang magtatrabaho ng dalawang network sa ulo? Kasi you know, these are the two ecosystems na magkaiba. So hindi mo siya pwedeng aralin sabay. Although may mga tao, okay, sige, may mga alien na siguro kayang pagsabay yung tatlo, pero for normal specialists, makakapag-focus ka lang into one vendor. So when an telco operator buys or plans the capex, una niyang titingnan anong vendor ang bibilhin ko. And pag napag-desisyon na nila yon na okay, for now Huawei ang bibilhin ko, package deal na yan. You'll have to buy the RRU, you have to buy the baseband unit, you have to buy the software from them, and you have to buy, o hindi naman have, but andyan na, I mean, I have to buy your service para buhayin to, para i-interoperate tong mga to, and to have to optimize the site. So what it creates vendor lock-in, it fosters dependencies, and it's less and fewer vendors. Bakit less and fewer vendors? Syempre, ano to kailangan mong kumita, and ang hirap kunyari ako, kung meron akong 1 million, makakagawa ba ako ng isang kumpanya para makipaglaban sa mga to? Pag nakuha na nila to, usually, if a telco operator gets a vendor, that's for like 3 to 5 years, and babawiin pa nila yon. So talagang less the vendors ka, and this network of operators would be dependent on these vendors. Okay? So alam na natin, traditional RAN, ano yung situation ngayon? So what is the principle of Open RAN? So an Open RAN is the manifestation. Actually, I have to highlight this. Open RAN is not a technology per se, kasi the technology is 5G. The technology is 4G. Okay? The technology is radio access network. The technology is the radio access technology. Okay? RAN. But Open RAN is not a technology. I think it's if I have to put it this way, it's like a movement. Okay? It's like parang usapan ng mangbabarkada. Parang ganun ba? Parang it's an Open RAN is a manifestation of a broader technology move. Yun. Tama, movement. Sabi ko. A broader technology move called disaggregation. Okay? Observe, hindi lang sa telco, but for other, or for IT. I mean, outside of the telecommunication, if you go into the IT, disaggregated sila, modular sila. I mean, you can mix and match platforms for an organization, for a company. So nung naisip nila, bakit hindi natin gawin to in telecommunications, in cellular technology, in radio access network? I-disaggregate natin, i-modular natin. So, and then i-open natin para maraming pwedeng sumawsaw or pwedeng gumawa or pwedeng mag-contribute. Okay? So disaggregation is the splitting of the system into smaller subsystems. Disaggregation means the separation of the hardware and the software. Or dapat sa hardware, meron pa yung subsystem pa. So pinag-iwalay mo yung software, tapos iniwalay mo pa yung software. So for Open RAN, we focus on the disaggregation of the radio access network component. So if you see, you have the core network. CN means core network. Ito pala. CN means core network. You have the RAN, which is the radio access network. Okay, RF is radio frequency, and UEs is a user equipment. So ano user equipment? That's the phone. That's the equipment. In the 3GPP, they call it the UE. So kasi may mga nodes yan sa mga tao, they call it a phone, mobile phone. But for technical people, it pertains to the terminals as the UE or the user equipment. So sila yung mga nasa end ng network. So ang Open RAN principle nito is you open the hardware, you open the software, and in between yung sa mga tawag dito, sa mga interfaces niya open din. So and then you have the backhaul na of course we have to open it, okay? And so let's go back to the traditional network, traditional RAN. The RAN can be a different vendor, pero dapat isang vendor lang. But then ito core network can be a different vendor. Yan, pwede yan. For example, you have a core network which is Nokia, and then you have the RAN or a radio access network which is Huawei. And yung interoperability nila established na in the industry. Wala na problema dyan. Although, by experience, may mga sisihan pa rin, may mga turuan. But in a way, the interface between core network and RAN has been established. So, pwede kang bumili ng ibang vendor sa core network, pwede kang bumili ng ibang vendor sa RAN. Yun, pwede yun ngayon sa traditional RAN. But we can go further by opening RAN itself. And in the TIP or the Telecom Infra Project, meron sila dong project group also what they call an open core. So meron ding open core silang pinag-uusapan. Since open RAN to, hindi natin napag-usapan to, bahala na sila. I mean, you can go read it. So if you're in the core network, you can read it. There's also open core. So gusto na rin nilang i-open yan. But for us, it's an open RAN. So we disaggregate the hardware and the software. So yun yung principle. I-open lang natin. Di ba? Maganda pag open, walang tago. Sa mag-asawa, kailangan open. Sa mag-shota, kailangan mag-open. Sa magkakaibigan, kailangan open. Dahil pag close ka, wala kayong mabubuong relationship. So siguro pwede rin natin i-apply. So wala kang mabubuong relationship dito sa network kung hindi ka open. Kung kayo-kayo lang, di ba? You can sit with us, parang ganun. So, yun yung principle natin dito. So, Open RAN, disaggregated RAN. Okay? So, compare natin. So, we have the core network, traditional RAN, and then you have the UE. Now, if you want to open the RAN, so, papasokin natin yan. Kita natin yan. In 5G technology kasi, they have designed it that you have the CU, which is the centralized unit. You have the distributed unit, and then you have the RRU or the radio unit, and then you have the front haul, yung mga interfaces dyan. Sa traditional RAN, sa 5G, lahat yan isang vendor. Okay? But now, if you want to open the RAN, pwede na yang iba-iba. Okay? Kasi basically, these are computers. Okay? These are just computers na sa traditional RAN, computers na inibang itsura, tapos nilagyan ng logo nung kumpanyang gumawa, nag-develop sa kanila. Because, well, sila ang nag-develop, so may karapatan silang lagyan siya ng label. But for Open RAN, this can be an COTS or it can be a commercial off-the-shelf equipment na nabibili mo like siguro 10 years from now, baka makabili ka sa Raon ng ganito. So, which is a joke, actually. But hindi siya joke pala, pero may possibility, di ba? Or a CDR King, nagbebenta na ng centralized unit or distributed unit. But anyway, kidding aside, COTS is a commercial off-the-shelf. I mean, any vendor can sell. Okay? Hindi lang Nokia. I mean, Dell can sell a CU, a DU, an RU, or HP can sell. Okay? Or Lenovo can sell these things. They can go into RAN na dati IT lang ang pinag-uusapan, but they can go into it. But na-open to. And one key characteristic ng Open RAN, ito yung dinagdag nila, is the RIC, which would be a separate, I think will be discussed later on in the series, but it's a separate discussion. But to give you an overview, RIC is a radio access network intelligent controller. Ito yung key na idinagdag natin sa Open RAN. So, ito ngayon yung magko-control. So ano ba tong definition ko dito? Radio access network intelligent controller RIC is a software-defined component of Open RAN architecture that's responsible for controlling and optimizing RAN functions. So yan yung RIC. And mind you, RIC is programmable. So what does it mean? And also I had to highlight it is software defined. So papasok na dito yung cloud. RC can be in the cloud. It can be software defined. I mean, you don't have to have a hardware. It can be housed into an AWS server running a platform na programmable. Na I mean, anyone can offer the service na meron akong feature na pag ganito na kadami ang users, i-load balance ko, ililipat ko sa iba, or you have the self-organizing network is a thing now. Nangyayari na yan ngayon for a network. May self-organizing, actually may artificial intelligence component na or machine language na yung network na nag-iisip na paano ko pagagandahin ng network. Wag tayong yung mga nasa telecom, wag tayong matakot na mawawalan ng trabaho because of this. Because we still need people to check these things. But mapapadali yung trabaho because it will be intuitive. It will be faster response to some problems, especially for example, mag-e-election na naman, magkakaroon ng rally. It's a big headache actually for us sa amin. Nung election, I mean, kanya-kanya sila ng rally and kanya-kanya kami ng tingin. Before the rally, we have to check that area. Kung kakayanin ba yung mga tao, ilan ba ang pupunta. So, natuto akong tumingin ng, kino-compute yung square meter, people per square meter. Ito ang tao. So, doon nabibilan namin ilan bang taong pupunta dito sa area nito. But with RIC, we can program that. Okay? So it's a different discussion, but yeah, I have to highlight that. So you have the RIC. And then lahat open. Okay? So, yeah. So what does open mean? So the main goal for using Open RAN is to have an interoperability standard for RAN elements. Open refers to the intentional capability of the software, the hardware, and or interfaces to comply with an agreed upon standard. So, ito yung mga key highlights dito. Ito yung mga highlights dito. You have intentional. So, napag-usapan yung agreed upon standard. Pag sabi mong open, hindi yung open na mag-open tayo, gusto ko ganito, parang magulo. Okay? Kailangan umupo, pag-usapan, and kailangan i-standardized. So, kailangan standard siya. Pag open, ibig sabihin, pag dumami yung mga players nagkaroon ng maraming vendors, kailangan meron kang sinusunod para pag nag-program ako, pag nag-design ako ng architecture, nag-design ako ng software, nag-design ako ng application, is I adhere to the standard. Para pag sinalpak ko yan, plug and play. Di ba? So parang ano lang din yan, parang if for people who are into PC building, okay? So actually PC building is somewhat open because nakadepende ka pa rin kasi sa architecture ng CPU eh. So if you are Intel based, so yung MOBU mo o yung motherboard mo kailangan based on Intel. Or if you're AMD, dapat based siya sa AMD. But beyond that, yung mga peripherals mo is open na. You can buy from any vendor sa mga GPU mo, for your memory, for your SSD, for your Wi-Fi. Open na yan. I mean, alam na nila yung bus saan nila pupunta, kung saan sila sasalpak. Because they have a standard. So, much like that, itong open na to means that napag-usapan niyo yung standard for the software, napag-usapan niyo yung standard for the hardware, and the standard for the interfaces. So it should be open source software, it should be open source hardware, and it should be open interfaces. So open source, sa mga sa inyo nakakarinig ito, pag sinabi mong open source, much like ano ba to, Android, so kahit sino pwedeng gumawa ng games or na applications sa Android na ecosystem kasi open source siya eh. Okay, so alam mo kung paano ka makipag-interoperate sa kanila. So that's open sa Open RAN. So we have to highlight also what they call this, the terms. Okay? Para in tayo, di ba? Pag alam mo to, I mean, wow, in tayo. So para tayong frat. Yeah, sorry. Anyway, sorry. That's not good. Anyway, Open RAN is you have these terms, okay? So pag open space RAN, okay? Ano ba? Sabi ko, Open RAN basic concepts can be misunderstood, okay? And it's necessary to know how to differentiate them. So let's be clear. We have these three key terms, okay? Open space RAN is a broad term to describe the disaggregated RAN solutions built on open COTS hardware and open interface standards. So ito yung pinag-uusapan natin ngayon, open space RAN. Then Open RAN as a one word refers to the TIP. TIP is a telecom infra project. You can Google it. It's ano ba tong nilagay ko dito. TIP Telecom Infra Project is an organization formed in 2016 to collaborate, aiming to have global access for all. So ito ang mga ano dito, ang mga bubuo dito is like Intel, Facebook, Nokia, Deutsche Telekom. So mga vendors, mga network operators yan. Sila yung mga alam mo yung ngayon, no man is an island nga daw is, di ba, sabi. So, kailangan yung mga network operators around the world nag-uusap yan. And if you're familiar, katatapos lang ng World, ano to? Yung sa Barcelona, I forgot
Mobile World Congress.
Mobile World Congress. Thank you, sir. So the Mobile World Congress, nakaka-conclude lang nila this week. So yan, dyan nag-uusap-usap yan, nag-share yung notes yung mga operators dahil hindi naman sila, ang mga operators kasi hindi naman makakalaban yan dahil kung iba-iba bansa ha, I mean, they can share information, they can share experiences in their network. So yun, isa to sa mga organization or na umuupo sila, nag-uusap-usap, nagkukwentuhan, kape-kape, gano'n. Na paano ba natin pagagandahin? Paano ba tayo kikita? Paano ba bibilis yung throughput natin? Yung mga bata kasi ngayon gusto na 300 gigabytes per second, di ba? So diyan sila nag-usap. Isa yan, Telecom Infra Project. So, Open RAN as a single word is a project group. So, if you go to the TIP site, meron yung ibang group eh. Meron nga dyan yung Open Core. So, yan, merong nag-uusap-usap din. So, mga idea nila doon sa domain nila. But for us, we have the Open RAN. So it's a concept defined as a vendor-neutral disaggregation of RAN at both the hardware and software levels on general-purpose processor-based platforms and implementing open interfaces between components. So this concept includes virtualized and integrated RAN solution. Also, I have to highlight also na actually virtualized network is happening already without the Open RAN. I mean, when you say kasi visualize, you put the hardware or the computation into the cloud. So meron na mga itong mga telco vendors na to, they're selling CAAIS, yung service as software as a service, and then you have hardware infrastructure as a service. So na-virtualize na, meron mga nagganyang na-offer. But it's still proprietary. Okay? Sila pa rin ang may hawak. Kung Nokia, virtualized network, Nokia siya. If Ericsson, Ericsson. Pag Huawei, Huawei. Okay? So, yun. Highlight ko lang yung virtualized. Kasi, magka-connect kasi yung Open RAN sa virtualized network. But, actually, virtualized network is being realized now. Okay? May nag-offer na. But, what we're aiming is Open RAN. So, i-open natin. Virtualized, pero open. Okay? So, ano pa? Ito, okay. O-RAN. So, it refers to so may isa pang grupo. So, mayroong tinatawag na O-RAN Alliance. TIP is basically anything under the sun, basta telco, or basta connectivity ang pinag-uusapan. So, you have vendors, you have IT companies, you have operators. In the O-RAN Alliance, this is basically targeting Open RAN. So the O-RAN Alliance is an operator-founded organization defining standards for next generation architecture and open interfaces to ensure interoperability. So ito yung sinasabi natin kanina na pag open ka, kailangan tayo mag-usap-usap, kailangan natin mag-set ng standard. And that's the O-RAN Alliance. So, yun. So, para sa mga umattend ngayon sa ating mga 500 participants ngayon, na tayo ngayon dahil we know open space RAN, open RAN, O-RAN. So pag may makakausap tayo, excuse me, magkaiba yan, di ba? So tandaan lang natin to. So at least meron tayong idea dito sa mga to. So okay. So to conclude, okay? So to finally settle the question, what is Open RAN? So, balikan natin. Open RAN means Open Radio Access Network. So, you highlight Radio Access Network, which is an existing architecture na for the past decades has been changing lives. I mean, imagine niyo nung unang panahon na sa mga nakaabot siya na wala pang cellphone, okay? Matatawag ka via wireline telephone, may party line ka pa. So, ibang-iba talaga ang nangyari ngayon. Pwede ka nang malate. Anyway, so, hindi, joke lang. Parang kasi kasi pag tawawa ka, makita tayo ng 9, talagang pupunta ka ng 9. Kasi nga, wala ka ng way para makipag-communicate. Ngayon, on the way na ako kasi may cellphone ka na. So, kidding aside, it actually changed our lives. I mean, we're interconnected. Mag-abroad ka noon. Paiyak-iyak ka kasi pupunta ng Saudi si tatay. But now, no, we can have Zoom, okay? You can have Teams, you can have Viber, you have WhatsApp. Pwede ka makipag-usap kahit saan, okay? It changed our lives. So, you have the radio access network. Pero, yun nga, since dinevelop siya ng mga vendor, proprietary siya. Siyempre, dinisign ko to eh. So, I mean, ako may karapatang magbenta nito. Ako may karapatang So, nagkaroon kayo ngayon ng mga iba-ibang company. So, then, yan nga, na-develop ng radio access. You have 2G, you have 3G, 4G, and now we have 5G, and now we have 6G. Di ba tayo nakakahinga, may 6G na. So, radio access network is really developing fast. But then, you add open. Okay? So, we have the technology, pero gawin natin para mas masaya, mas marami, mas masaya, di ba? So, we open it. So, open means you have a lot of collaboration. Open means freedom to innovate. Okay? Ang daming pwedeng maraming magagaling eh. You can have a startup focusing on this. I mean, startup developing software, you can innovate dahil hindi na siya nakatali into a single vendor. Anyone can join the party. Okay? Freedom to choose for the operator. Hindi na sila nakatali into a vendor na pag hindi ka naka-deliver, okay, I have the right to look into other suppliers, di ba? So it's a freedom to choose for the operators, and then faster to market kasi nga plug and play, you can buy. So if this is an industry movement that develops disaggregated interoperable radio access network solutions leveraging on general purpose processor hardware. Ito yung mga COTS, software-defined technologies, ito yung mga nasa cloud, and open interfaces based on industry standard. So let's go back to the architecture. So you have the radio unit, you have the cell sites, and then you have the distributed unit, you have the centralized unit. So the processing happens here, and then you have the core network, and then you open this up for everyone to develop. So, alam mo yun, mangyayari, kasi as an experience, for example, nagkaroon ako ng problema sa isang radio unit. Ang problema is radio unit ko, hindi na maayos. So, you remember the key challenges sa mga operators is better performance. So, sa isang area, for example, sa Las Piñas, ang pangit ng performance. Yung pala, yung isang area doon na serving ng isang cell site, faulty yung radio unit. Ang nangyayari kasi, if they plan for a capex, they buy this certain amount of radio units from a specific vendor. And you have to order it in advance dahil yung mga vendor, hindi nila yung ginagawa agad-agad. Ginagawa nila yan per order. Kasi nga naman, hindi mo yan pwedeng ibenta sa marketplace or sa hindi mo pwedeng ibenta sa Shopee na kahit sino pwedeng bumili. Kasi bebenta mo yan based sa order ng operator. But in Open RAN, anyone can, you can now use a COTS equipment na hindi ka na, yung supply chain mo is hindi na ganun ka-restricted because you can buy from anyone. Kasi nga open, anyone can develop a radio unit. And basically, these are computers, di ba? So, any computer siguro, we can because it's still an open discussion. The standard is being discussed. So, anyone can contribute into the hardware. So, ito yung mga radio unit, the distributed unit, the centralized unit. And then the software that's running on this hardware can be are open also, so anyone can develop, and then the interfaces can be open also. And now the question is, sir, gagana ba yan? Di ba?
Sir Jem, sorry, sorry to interrupt, Sir Jem. We need to
yes.
fast track.
Last na. Oh. So, para sumegway tayo sa next topic, ayun ang next question. Sir, gagana ba kung open yan? So, yun na ngayon, yung interoperability. Kasi for me, with open interfaces comes ensured interoperability. And dyan ngayon papasok, paano ngayon gagana tong mga to? We have Open RAN, okay, that's a very promising future, but what do we expect on the interoperability? And that will be discussed on the next topic. So that's it for me, and thank you for listening.
Good morning, everyone. So I'm Mon, and we'll be discussing about Open RAN interoperability. So this is one of the advanced course in Open RAN Academy, Asian Open RAN Academy, and we'll give you a brief overview on what's in this course. So again, interoperability. Key concept is opening the protocols and interfaces between these various building blocks. So you got a lot of component in a typical radio access network, and what standard wants is anyone could have a play on which part they are interested in, or experts. No? So they don't have to be a large organization like Nokia, Ericsson, or Huawei that has to do end-to-end. That's what we have now in our current telecoms. No? So another feature of this one is the RAN Intelligent Controller, or RIC, or RIC. And it adds programmability to the radio access network. And this is what was discussed on the previous speakers, that allows Open RAN to be able to have an intelligent component on it to maybe distribute the load, tweak the RF signaling to give more signal to an area na mas maraming users, okay? And then i-recalibrate at some point. So, and additional here, this intelligence, some sort of intelligence and fine tuning is actually happening even on Wi-Fi network nowadays. No? So mga 5 years ago, yung channeling of wireless networks, no, it's fixed once you install it, or once you booted it up, hahanap siya ng channel kung saan walang interference masyado, and then doon siya mag-stay. Nowadays, you could program it na early, you recalibrate, especially for a high traffic environment or high density access points, no, like a condo or what. It could tweak itself and be optimal para less interference, mas high yung bandwidth, and then mas seamless yung operation sa users. Global mobile operators also, of course, are pushing for open and intelligent and virtualized, no, and fully interoperable RAN solutions, because they want to minimize, no, or if possible, eliminate proprietary hardware ecosystem, as what Sir JM mentioned. No? So you don't want to be locked in on vendors, and each and everyone in the current telecoms, no, before Open RAN, have their own play on why they want vendor lock-in. Of course, yung end-to-end testing with the hardware and the software, may benefit yon na single vendor, but for the user naman, then you are now locked in to that specific vendor. No? So siguro sample ko dito would be difference between Android and iPhone. So iPhone, end-to-end, that is owned by Apple, no? From the software to the hardware, even the distribution, that's Apple. No? So it's I wouldn't say locked in the proprietary, but they have their own ecosystem. Android, on the other hand, well, it's just the software and, well, basically the platform. So anyone could manufacture their own hardware, you know, and integrate it with Android. No? So that also made, if you could see then yung trend, you got cheaper Androids than iPhone, and depending on the use case, that could be good enough for most people. So we could analogize that for telcos, that might happen the same with Open RAN, and that would in turn foster technological innovations with AI and machine learning, continuous integration and continuous deployment, software-defined networks, network function deployment, and again, supply chain diversity. Because now, let's say you are a tech company, you want to have a play in telecoms, no, a radio access network, but you don't have expertise on RF, no, but you have expertise in AI and machine learning. No, you could now start and concentrate your resource and R&D on that specific component, okay, and be the best in the field, and then now you could fight it out, no, even with large organizations, no. Kasi the drawback for large organizations is if they want end-to-end Open RAN compatibility too, they would allocate various resource and engineers per component, no. So may pros and cons, depends on where you're at, but this allows smaller players to get into the telecoms, no, or radio access network. So anong tingin ito? Interoperability. We could have an example here with healthcare, no? On how this developed, no? Yung interoperability. So if you could remember, no, if you're already born noong 1960s and 1970s, kasi Ma'am Tony nandun. Yung doctors natin, they had to use fax, phone, and mail, basically to share patient record. Ayari kay Ma'am Tony mamaya. But that's how they share information, no? That's before connectivity, and around 1980s to 2000s, so we got now internet connectivity and electronic health records, no? Na brought about by, well, digital interoperability. Okay? And this in turn made yung health data exchange become a priority, kasi diba, if may sakit ka and yung data mo is nasa isang hospital, and let's say nasa probinsya ka, bigla ka nagkasakit doon, di ka na makausap, diba, and yung data mo is cannot be shared kasi walang interoperability standard or walang communication standard between healthcare systems. Kailangan lahat i-retest nung new hospital mo saan ka dinala, no? Yung kung ano yung mga sakit mo kasi hindi ka na makausap, ano yung possible treatment mo, ano yung mga gamot na iniinom mo, diba, for possible conflict with medicines na introduce na sa'yo. That basically takes a lot of time essential time that could have maybe save you from dying. Kasi kung isang click of the button, di ba, meron silang coordination with the other hospital, with proper data sharing agreement, of course, they're gonna be able to send yung health records mo. The doctors would have a look ni medical history, ano yung inom mong gamot, ano yung current sakit mo. Okay, they would be able to diagnose your issue a lot quicker. No? So, sample, may nag-collapse lang dyan, di nilala kung naka-stroke na, may epilepsy, or whatever sakit, no? But only to find out, di ba, pagdating ng health records kagad in an instant or near real time, they would able to see, oh, diabetic. So we could maybe check kagad yung sugar level, baka nag-crash lang. Then they could maybe inject insulin, di ba, to stabilize it and save that person. Hindi yung baka inatake sa puso, baka may blockage sa lungs. So dami pa nilang test na gagawin that would again take time to have results, no? Only to find out, well, it's a sugar crash na nangyari. So nowadays, no, 2010 to current, no, basically that's what's happening. Interoperability becomes an essential in healthcare ecosystem. This would enable basically enable organization not only in healthcare. No, if you put this into context to any verticals, no, you could now act upon vital data, no, and deliver cost-effective quality care. And with healthcare, no, relating it to telecoms, we got a lot of mobile devices, no, that stores our health records. No? Gaano katagal tayo naglalakad, ilang stairs yung kinlive natin. So, well, cellular phones and smartphones nowadays is basically a tracking equipment, no, so to speak. And ang dami niya sensors. Then if you have yung mga smartwatches, they have now different telemetry, no? At the wrist, in your wrist. You got heart rate monitor, you got SpO2 for oxygen level monitoring, pedometer, even have audible, no, loudness sensors that would warn you kung masyadong maingay yung environment and notify you na, oh, medyo maingay dito. You might damage your hearing if prolonged exposure. And nowadays we have ECG, no, on some smartwatches na used to be it's very big equipment tapos napalit nila. And with interoperability, diba, you could take a reading, okay, and store it sa phone, and then at some point, no, although hindi pa supported sa Philippines, no, health institution could access that information and have a read on yung historical biometrics mo. So with open and interoperability, we have this distinction, no, between 4G, we used to be 4G and Open RAN, nowadays starting 2019. In 4G, as mentioned din ni Sir Jem kanina, no, this component is closed and proprietary na hardware and software and protocols, no. So from baseband unit to remote radio units, they are controlled by the organization kung saan mo bibili niyan. And what Open RAN is attempting to do is, well, not just break and segment yung mga components. It's more of we open the interoperating these specific components, open the interfaces, standardize the protocol. So anyone, if say they're good at developing radio units, no, they could just concentrate on doing radio and be very good with it. Okay, if they're good with distributed units, then just develop that distributed units and component. No, and I would predict, no, if this goes as planned, that technology R&D, no, and yung adoption and yung progress, it's gonna be leaps and bounds as compared to what we have with the proprietary, no? So with proprietary and closed interfaces, you would be having a hard time developing na specific components. So if let's say I'm Nokia or Ericsson, no, I have to improve each and every component per next generation. And they have limited engineers. I mean, they do have resource, no, but the engineering limitation is still there. Money too, no? Or funding, it's also limited. But if you break it away, even small players that maybe 2 or 3 people engineering team that has a very good idea on how to improve, let's say, the radio access network, they could play with, let's say, maybe they could invent some additional optimization on radio transmission and reception. So with all those components that has been broken apart, no, for various reasons, you need now intensive testing na end-to-end. So unlike before that it was one vendor and they control the software and the hardware, they know how each and every component would react, no? And yung specifications niya, and yung capacity niya, and ano yung mga tolerance niya on certain environments. But with Open RAN, broken into various components, interoperability now becomes a thing. As we've known, if meron sa inyo mga networks, no, engineering, sometimes you see network equipments that would say compliant ako sa spanning tree protocol na standard, no, for Ethernet networks, and you have 2 devices, vendor A and vendor B, that's supposed to based sa datasheet nila talks as and complies with STP. But once you operate it, tas nagkaroon ng cable loop, diba? One device is not reacting as intended, or iba yung interpretation ng vendor on how it was supposed to implement STPs, hence nagkakaroon ng broadcast storm within the network, no? But well, standard wise they say that they comply, so we don't want that happening on critical infrastructures like telecom. So there is a push, no, to have intensive testing and integration to make sure that all components are interoperable and complies to Open RAN standard. So that's a good document, no, yung sa baba, yung importance of interoperability testing for O-RAN validation, and meron siyang mga sample on this figure, like meron siyang distributed unit emulator na nandun yung iba't ibang components, and then for, let's say, conformance naman, no, for radio unit testing, no, meron kang vector signal analyzers, meron kang signal source, and then meron ka pang mga sequencers, test sequencers for automating hundreds, no, of tests, to include pag gagawa ka ng conformance test suite. So, but this has to be defined while the standard is still being developed as we speak, no? It's basically it's ongoing yung progression niya, no? The conformance testing sheet also needs to evolve with it. So okay, on the actual course, no, marami tayong reading materials since that I think we only have 4 to 5 hours, no, for lectures on the course for interoperability. So a lot of reading materials would be off the lecture time, no, but you would now be able to relate and understand bakit ganun yung but ganun yung mindset of O-RAN. Like for this one, meron tayo dito, how about Open RAN in satellite communications, no? So I think it's a 4 or 5 pager document, no, from Analysis Mason, and it's a good case study that saying here that yung terrestrial equipment yung magkakaroon ng say on how satellite communication would be able to adapt na using Open RAN. Kasi well, as you know, with satellites, maraming proprietary communications yan. So this could be a good use case for maybe some sort of Open RAN type na deployment in the future. Now, to recap, we got 3 major components of Open RAN, O-RAN 5G. No? So we got the central unit or OCU, we got the distributed unit or ODU, and then we got the radio unit or ORU. So that's 3 major components. So additional recap, no? OCU, responsible for packet data convergence protocol or PDCP. Yung ODU naman, distributed unit, this one is responsible for all baseband processing, scheduling, radio link control, medium access control, and then yung upper layers ng physical layer for radio transmission. And of course, you go lower layer no, sa physical, the ORU is dito na yung physical layer processing, no, including yung mga analog components na ng radio access network, which includes yung radio transmitter and receiver. Okay. So, open standards. Now, in Open RAN, there were two dominant organization standardizing bodies. No? So, si ORAN Alliance and si Telecom Infra Project. And they want to ensure that industry would comply to standard interfaces to be able to interoperate between various components. And these two big shots in Open RAN, they basically align and they develop yung sharing of information, reference specification, and joint testing and integration efforts. So they practically join hands and say kailangan nating mag set ng standard for everyone to follow. So open interoperable standards, this would define interfaces between various components. And if everyone would comply, and assuming parehas ng implementation features, not unlike sa computer networks, at least din yung experience ko kasi, iba-iba, you have a standard from the IATF or IEEE, but how it was implemented by vendors is varies, both good and bad. So I think I could sample here sa network operations, so or network protocols, yung time to live in computer networks. Initially, the time to live was designed as time to live na if a packet is received on a router, the router should note anong oras ba dumating tong packet na to. And then it's gonna go through, of course, validation, processing, check ng routing protocols and routing tables, and then send out the data. But before it sends it out, diba, it would now note anong oras na ba to natapos i-process, check na kung anong oras na dumating yung packet, and then say sabihin natin 10 seconds, babawasan niya yung TTL ng packet ng -10, okay, before it sends out dun sa network. And on that implementation, at least the original concept of time to live, it was created to prevent broadcast storm, para at some point, hindi infinitely maglo-loop yung packet kung pabalik-balik siya within the infrastructure due to a routing loop. It's gonna die out kasi mauubos yung time to live, it's gonna get zero. But if you check out yung original concept of implementation of time to live, you needed a lot of data sources, right? And data structure to maintain that concept of time to live. Kasi pagdating meron kang data structure to tag that certain packet, anong time siya dumating. Pag e-exit na siya, meron kang additional data structure to store that, and then you have to compute, diba? Gaano katagal yung processing time, and then you have to decrement now that value dun sa time to live. And it took some time to realize na okay, medyo tatagal tayo dun for processing and we need additional resource. And we didn't want that to happen. So what the optimization on future implementation happened was, well, ang objective naman is not to flood the network. So as long as we're able to decrement the packet's time to live per router na dadaanan niya, then it's gonna die. We don't have to consider na yung actual time it took to process it. And well, that was before, kasi nowadays milliseconds na rin naman yung processing ng packets or microseconds even sa mga high-speed networks. It did its purpose, diba? The TTLs gets recommended, and you don't have routing broadcast storm, or well, it would still be broadcast storm. Pwede pa rin mangyari yun, but the packets eventually gonna get dropped, assuming the number of hops was reached. But now mas efficient na implementation, since they don't have to keep the time kung kailan dumating tsaka kailan i-exit, as long ang naging optimization rule na lang is as long as the packet is gonna go out of the router, I'll just decrement the TTL. And on modern computer architecture, that's just one instruction set. So just decrement and then write it back sa packet and then send it out. So compare that with the initial implementation na diba? I need to note of the time dumating, time na lalabas, subtract it, and then kung ano man yung value na yun, yung i-subtract natin dun sa time to live before we send it out. So there was optimization, but nagkaroon na ngayon ng difference with implementation. And not only that, there was no standardized value. No? If we relate this to network, on what's the initial TTL. Diba? Although the TTL could be a maximum 255, no? Some byte. Some operating system would set their TTL paglabas 64 integer na 64. Some would be 128. No? So again, walang standardized numeric value for that. So that allows developers and implementers some wiggle room kasi don't lock them down, but that could also cause some issues, and hopefully that gets ironed out with yung mga interoperability standards ni Open RAN, no? When we do this network operations. So RAN Intelligent Controller as component nitong Open RAN, which has to comply of course with yung interoperability, but it has two forms. No, you got a non-real-time and near real-time intelligent controller. So the difference would be if you need to process something na milliseconds to a second, no? It's gonna be piped through and processed through what we call the near real-time RAN intelligent controller. But if you need something to be processed but hindi naman siya time sensitive, then you could send this job to what we call a non-real-time intelligent controller. No? So anything more than 1 second dito sa component na to pupunta. So open standards for interfaces, we have here from the ORAN Alliance, no? Yung basic diagram of interconnectivity of various Open RAN components, and they practically defined a lot of this, and they based it also on 3GPP standards, no? So that's what we've seen with yung initial speaker kanina from Nokia, no? So a lot of this came from that kasi well, it's still a telecom network. Okay. Right. So let's describe briefly yung mga components na to. So the open frontal interface. So this one is the interface that connects yung distributed unit to the radio unit. So this also breaks down into management plane and yung control user synchronization plane. And you can see it here sa diagram. Frontal interface would be this one. So again, it links between the ODU and the ORU. So you got here yung open frontal synchronization and then yung management plane. So these are when you're trying to locate yung open frontal interface, dito mo sila makikita. Although meron din component dito sa left side, no? But this could dictate, no? And this would dictate how and what calls and data are allowed to be interacted between the ODU and ORU. So that's how important that yung open frontal interface is. Now we got A1 interface. So si A1 interface naman, this one supports yung communication between the two RAN intelligent controller, no, for policy management, data transfer, and machine learning management. So, and to view it dun sa diagram kung nasaan tong interface na to, it's again, well, it manages between non-real-time and near real-time RAN intelligent controller. So that A1 interface is the link on how jobs and tasks and results are being coordinated between these two controllers. Then next, we have O1 and O2 interfaces. No? So this one connects yung service management orchestration, and then yung radio access network elements. So, and this includes near real-time RIC, OCU, ODU, ORU, and basically the Open Evolve na node B na component. And if you could see yung diagram, again, going back, yeah, again, more interface to sa yung O1 and O2, no? So service management orchestration papunta sa ORU and then OCloud. So hence nandito yan. And then si O1 dun papunta sa O-ENB. And again, all these interfaces needs to comply to a certain standard for it to be interoperable and be able to use it in an Open RAN deployment. Next interfaces, we have yung X2 and XN interfaces. Then si X2, meron pa siyang X2-C, meron pa siyang X2-U, which are described in detail sa Open RAN documentation. And yung former kasi is for the control plane, and then yung X2U would be for the user plane, as the small letter CNU describes. No? Yung XN naman, basically these are broken down into controls and user subtypes. No? So again, depende. Pwede kasing maraming components sa X interfaces. So kaya naging XN, pwedeng paramihin yan. And you could see it here. No? So yung mga X interfaces links to yung OCU, OCU-CP, tsaka OCU-UP. Okay? And yeah, this one basically sends out data, no? Palabas dun sa main Open RAN infrastructure. Then we have the NG interfaces. This one control and user plane interfaces that connects an OCU control plane, and then yung OCU user plane to the 5G core network. Control plane information of this one goes to the 5G and mobility management function, or AMF, and requires connection and session information from the user equipment, no? Yung mga cell phones or ano naman yung user equipment na pwedeng gamitin for the 5G network. And if we could see yung diagram, no, this would basically be handling yung a lot of the aspects ng routing, forwarding, and tunneling ng mga user function on the user plane. And this is yung NG user plane, and then NG controller plane. So again, medyo papunta na to sa 5G core network. This basically is outside yung Open RAN, but this allows external components to talk to the Open RAN environment. And then we have yung F1 interface. This one again broken down into the control and user plane subtypes, and it exchanges about frequency resource sharing, and other network statuses. Okay. One OCU can communicate with multiple distributed unit via the F1 interface. See here sa diagram. No? So F1 would be here. No? And again, if may mga conflicts with frequency, or they need optimization, they need some other information to tune the environment, this could be this is where the instructions and metrics are going to be passed on from the ODU to the OCU, and vice versa. And then the moment that they have that data, it could get passed to the RAN intelligent controller. This would decide anong channels tayo mag-allocate, transmit, anong antennas yung ipa-fire up natin. And it's gonna cascade the instructions back to these components, and then you're gonna have the setting that you want. And if there's any conflict, no, let's say biglang may binanggaan ka pa ng ibang channel na hindi dapat, no, there's gonna be some feedback mechanism to say na, oops, okay, may nagiging noise tayo sa kabila, so we need to tune this down, okay, or move away from that specific channel. Okay. And then lastly, I think this is the last one. So we got E1 and E2 interfaces. This connects to disaggregated OCU, user and control planes. And this would now be able to transfer configuration data and capacity information between yung two na OCU planes. So E1 and E2, this would be it. Again, it does connect with each other, yung OCU and OCU CP, OCU UP, okay? But also connects to the near real-time intelligent controller. So again, any configuration or any information that this needs to be processed, diba? It's gonna get sent to the near real-time RAN intelligent controller. And it depends, diba? Kung maraming data and hindi kaya i-process agad to or hindi naman siya mission critical, it could pass it via the A1 to the non-real-time RIC. Okay? And then once the processing is done, then they could cascade yung mga information back dito sa various components na usually, again, various disaggregated components yung design na to so that they would work seamlessly na parang hive mind. It's one big radio access network. And we would now go yung next set. So how do we test interoperability for ORAN? Now, luckily for us, ORAN have released document. No? They are now on version 4 and the latest version was released just last year, 2022. If I'm not mistaken, around July 2022 nirelease. So, 6 months old. That's the latest version. ORAN has yung test and integration focus group. And they basically release yung end-to-end test specification. And it's a big document. This is gonna be the Bible for testing. It's not as detailed as I wanted it to be. But yeah, I think the technology is still being developed. So over time, it's gonna get more detailed. But if I could zoom this a bit for the older people. So yeah, you got discussions on system under test, test and measurement equipment and tools. You got mobility classes, radio conditions. So you get the LTE 5G testing. You got the registration and the registration on a single network slice. A lot more, no? Even yung mga security testing, they have some sort of guidance, no? I wouldn't say intensive or extensive, but it's a good document to start with. Got some voice service EPS fallback, voice over NR, and even video testing for video service, video over LTE. And a lot more. Again, for security, you got mga denial of service attack, how to test it sa network layer or sa if you're attacking the S plane or the C plane or the near real-time RAN intelligent controller by the A1 interfaces. But yeah, a lot of this is at least on the security testing sa network layer. Ocloud exhaustion, even the load and stress testing of various components. They have it stated here. So yung typical nila for the testing would be you'll have a test description and applicability. Ano yung setup and configuration, what's the recommended, again, recommended to, hindi siya mandated, no, na test procedure, and ano yung magiging requirements and expected results. No? So, we'll go into an example later para you got a view kung ano yung mga various components dito na you could read. And this is, well, this is going to be a required reading on the course. And it's a bit big, no? Around 225 na, no? na pages. Okay. So yeah, that's the ORAN testing document. To have a peek anong detail na laman niya, no? So meron siyang tinatawag na system under test, no? So you got yung user equipment, diba? Connected to the ORAN environment, which is basically that's the entire system under test. And then you got yung S1 and NG connectivity papunta sa 3GPP core. But yeah, ultimately it's gonna be an end-to-end key performance indicators, no, that needs to be read through, no? Ano yung expected and ano yung result the moment na ginawa natin yung test. Basically yung ang one component dito, no, internal functionality and architecture ng SUT is typically out of scope. So you want just various components to be tested lang for interoperability. Yeah. So sample here, yung next natin. No? What if we want to see how this relates to a common interoperability testing, no? But in relation to security, which is shameless plug, no? I think March 24 will have around 3-hour session for current state of Open RAN security. So if you're interested for that topic, please do sign up. So like this is part of yung end-to-end testing document ni Open RAN. No? But I did get this an example for you to have a view na ano yung content. So sample here is how do we test ano yung magiging reaction ng system for a blind exploitation ng well-known vulnerabilities over yung near real-time intelligent controller via the A1 interface. They're basically attacking the system via the network layer. So for the test description, they stated that this purpose is to test and verify that exploitation attempts of well-known vulnerabilities executed blindly against near real-time RAN intelligent controller A1 interface, which is, well, here, no? This part. Meron siyang hacker na supposedly nag-a-attack ng near real-time intelligent controller na A1 interface. If it gets attacked, again, ang note dito is well-known vulnerabilities, no? Kasi it is software. Software has vulnerabilities, and so if software is connected, it could get hacked. No? But for this description, the document is just stating that we just want to test for well-known vulnerabilities. No? So this means alam na natin. Merong documentation about it. May mga tools tayo to test it. It does not say na the Open RAN system or the ORAN system would be resilient against zero-day. Now, we got controls to be implemented that could minimize the damage, or if ever may nangyaring ganon, we could detect it immediately and do some remediation quickly. But yeah, for the testing, they cannot cover something that you do not know. So they stated here na well-known vulnerabilities lang. Attempt to exploit well-known vulnerabilities, which a lot of vulnerability scanning tools already covers. No? Hence, the notion here for the setup is, well, we need IP access, no? And IP address nung near real-time radio RAN intelligent controller A1 interface. Okay, now we could get to that and act as an emulated attacker and then attack the A1 interface. Typically, this would just use various vulnerability scanning tool like Nessus, Qualys, even open source one like Nmap or OpenVAS. I think OpenVAS already changed their name. Greenbow na yata sila now. So yeah, there's a lot of tools na commercial and otherwise na you could use to implement this. And again, hindi sila didictate ni end-to-end testing document, no? But binigyan ka ng guidance on saan mo ite-test, ano yung ite-test mo, and ano yung expected behavior. So what they were saying here is, well, blind exploitation, I throw out all the known exploits for all known vulnerabilities that could affect the A1 interface. That could affect the near real-time RAN intelligent controller A1 interface. And ideally, walang signal or walang degradation or walang exploitation na mangyayari. So that's the intended outcome. So for the test procedure, if you have networking background, this would somehow make sense. You want yung user plane traffic na could still be handled properly throughout yung system under test. So we got some sections here for reference, yung bidirectional throughput ng different radio conditions and data services tests and benchmarks are indicating correct behavior ng SUT. Basically, kahit tapunan mo siya ng vulnerability, ng exploitation traffic, ideally hindi affected si RAN intelligent controller, no? It's not gonna degrade yung SUT, no? So this basically makes sure that vulnerability scanning tool, though updated dapat yung mga database niya ng well-known vulnerabilities, kasi if you're using an old database of known vulnerabilities, then the 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 platform might be vulnerable to new known attacks na may patch na but hindi in-apply, no? But you're using old database for old vulnerability database, so that does not is not recommended. All this vulnerability scanning engines, they do have signature updates din naman, no? Think of it parang antivirus has signature update for known malware. Vulnerability scanning engines, they have updates for known vulnerabilities and how to test against it. Okay, so once it's set up, you have an updated database. You now want to execute the vulnerability scanning tool against the IP address nung A1 interface ng NIR, real-time RAN intelligent controller. And meron silang some sort of, I would say, guidance pa rin to, no? I mean, not sure kung how do you call yung this scan should. But yeah, they stated this specifically na I want to find out, of course, anong mga services yung open and accessible dun sa A1 interface. So they set this na dapat open tayo sa port, we could check all known ports from 0 to 65,535. Kasi, well, di ba, TCP and UDP ports are 2 bytes, no? So ito yung maximum ports, maximum permutation of ports. And we don't know kung may mga services or backdoors on different ports on the A1 interface. So the vulnerability scanning engine must be able to test all of this. But look at the second one. UDP ports, top 1,000 lang yung pinapatest ni Open RAN end-to-end testing document. Now, I would say na this came into light. So, define ko muna. Ano yung top 1,000? Top 1,000 is not port 1 to port 1,000 na UDP, no? So, meron ranking of known well-used ports na UDP that could be part of the top 1,000, no? That does not necessarily mean na ito lang dapat yung 1 to 1,000. Kasi may mga well-known UDP ports like, let's say DNS, port 53. It's part of the, if consider mo, it's under 1,000 siya. So, it's gonna get considered. But if, let's say, mag-SIP tayo na protocol, which is UDP port 5060, that's well outside the yung 1 to 1,000. So, yung top 1,000 is not 1 to 1,000, it's top 1,000 na most common ports, no? May listing for that. Okay? And then yun lang testing niya. But if ang maximum number of ports is 65,535, we're just testing a very small amount of UDP ports. And I guess that yung ORAN Alliance, that focus group that created this document, settled with 1,000 ports ng UDP is due to the fact that scanning UDP tends to be very slow. Kasi unlike TCP, pag nag-send ka ng probe, tapos walang service on the other end, di ba, you're gonna get a reset. Merong instantaneous na reaction for the system. Or, di ba, bababaan mo yung timing, time wait mo, di ba? You send a SYN packet, no? And maybe a few seconds, di walang response kasi dinrap pala on the other end. Then you could move along. Okay? And that could be optimized, no? In time-wise. Now, kasi connection-oriented si TCP. Now, UDP being connectionless had the issue na you could send a traffic, wala siyang yung three-way handshake na TCP na SYN, you could send a UDP probe and you don't know kung dinrap ba yun or pinaprocess ng tatagalan lang. Okay? Kasi wala ngang synchronization. Hence, it's gonna take some time. No? Based on my testing, if you scan 0 to 65,535 na TCP, if I tweak the timing options, I could do this in maybe 10 to 15 minutes. may scanning na yun. No? Just to check yung open yung ports, maybe 30 seconds to a minute. No, this could be probe. No, UDP, it would take me around 15 to 20 minutes kung lahat yun. And this was an optimized timing options na. So, yeah, I think it has something to do with time. But do note, this is just a guidance. You could opt, if you have a lot of time, no, scan all known UDP ports then. So 0 to 65,535 UDP ports. But you have to factor that sa time sa project planning, no, yung mga timing requirements, no. It would basically increase yung time to do the testing. Now, safe checks. Vulnerability scanners have this option na since this is on a test environment, no, hindi naman siya production, they are recommending that you disable safe checks. What is safe checks? If this is enabled, basically tests that could crash the remote system would not be sent. Yung mga messages or exploits that could crash a remote system, that are known to crash a remote system, they're not going to be part of the test. But, well, we do want to find out if the system is vulnerable or magkakaroon ba ng issue with the KPIs nung and performance ng SUT. And this being a test environment, disable that and send everything you got. Okay? Kasi at the end, we want to check yung susceptibility ng component sa exploitation against known vulnerabilities. No? And if ever it crashed, of course, magkakaroon ka ng recovery period if mabubuhay man yung yung mga components na to. Ideally may watchdog naman sila. But you would now be able to observe that when I sent specific exploitation traffic, the RAN intelligent controller crashed or caused some maybe process loop or process exhaustion within that CPU, and you'll notice yung performance impact, no, sa SUT. So yung expected results, of course, if you send that out and walang vulnerabilities yung A1 interface, there won't be any meaningful degradation. Now, of course, may processing na mangyayari pa rin yung mga traffic na nare-receive. Ideally, check lang na, oops, I don't need this, hindi ko naintindihan to, and then drop it and not actually process it for and consume additional resource. So you should not see any degradation ng service availability when you do security testing or load testing for that matter. So identification of well-known vulnerabilities is out of scope of this test. But you are basically just trying to elicit behavior. If I launch a vulnerability scanning engine against A1, meron bang mangyayaring signal or performance degradation on the whole Open RAN environment? Because again, this works end-to-end. So if one component suddenly is not responsive enough, no, it could cause the whole system to degrade too. Now, ideally, meron ka mga redundant component para saluhin yung load, no? But again, different implementations of and deployment would behave differently too. So, okay, so a lot. So sample testing platform, aside from building your own system na end-to-end, I saw this via V-Solutions, no? Good coverage. Ang dami nilang products that would allow you to test, no? Various components ng Open RAN. So from end user simulation ng 4G and 5G device, may ODU emulation ka pa, may E2, ODU, OCU, RAN emulation core test, core emulation RAN test. So ang dami niyang components, but of course, you're dealing with a telco environment. It tends to be expensive, no? If you want to test all of this. And then I also saw one product, no, from Firecell. This is the 4G 5G lab kit. If you're dealing with telco test, no, or even kahit school test, no, 11,000 euros is not that expensive, no, for a hardware and software. So if you could imagine, no, yung mga test equipments of nakita ko dati mga 2G, 3G equipment, no, from old Nokias na dinonate sa UP na for lab test, no. Ang lalaki niya to power that you need specialized power source, and then yung room may cooling ka pa, no. They were, at least on this form factor, no, they were able to reduce it to basically a desktop with nandito yung mga softwares for ORAN, alam mo, virtualized. And you got yung software-defined radios with 2 antennas. Then you have some smartphone with SIM card, no? And everything is self-contained. If you want to test this, then, well, if you want support, well, of course, it would cost additional, no? I mean, disclaimer though, I'm not a part of the Parcel IO, no? I just found that this is good platform, no? If you want a small, not too expensive equipment to have your own Open RAN or 5G lab in your school or in your organization if you're developing a component of this. So if you're, let's say, into software development, no, of various RAN components, you could have this and then develop your software dito sa loob, and then you could already test your integration, no, based on the standards. Okay, so specs niya would basically any FR1 frequency bands, basta less than 6 GHz, so that's good. 4G, 5G bandwidth, okay, do you support niya? And then power range, 17 dBm, 50 milliwatts, so up to 3 meters, which is good kasi it's a test environment, no? So you don't want it to be stepping over or transmitting beyond what you need. This might be required to be in a Faraday cage, though. I'm not sure yung NTC requirement natin with this. Say, or of course you'll need some license also or test license for this. Might be wrong. Not easy computer science with background ko, so please allow me to be wrong. Used for indoors, and then maximum 16 units for user equipment na for 4G, and then 10 for 5G. Okay, then they got good bit rate then, no? For 4G up to 70 megabits per download, they could perform it. And then 100 megabits. Hindi siya full 5G rate, no? But again, this is a test equipment. Good enough to test yung various components mo ng Open RAN that you want to develop. Okay. So key takeaways would be, well, Open RAN standards includes a lot of work on network controllers, management orchestration frameworks, and interfaces, and we want this to be able to comply with Open RAN standards so that they would talk seamlessly across various vendors, no? And while there is benefit on a single vendor approach, meron din, of course, bad side, no? Vendor lock-in, and then yung cost of how do you call this, support and maintenance, no? Kasi we do know of some cases that vendors would drop the price, no, for their equipment kasi that's gonna look attractive sa finance. So telco would be purchasing those components from that vendor or na nagbaba ng price, but yung long-term service, no, ng equipment and support, doon sila babawi. Okay? So ultimately, you still have to check ano yung total cost of ownership, no? Hindi lang magkano ba yung acquisition ng equipment, diba? Yung maintenance, yung support, yung RMA, that also, of course, has to be factored in. But sometimes, diba, I mean, you just think of it as being amortized. Kahit mura ngayon, in the future, in 5 years, kasing mahal na siya ng isang vendor na mas mura yung support, but may cost of money pa rin that you have to consider. But with Open RAN, you now have the benefit of the latest and greatest technology per component, but again, you now have the issue of you need to talk to multiple vendors as compared to dati isa lang kausap mo. So kung may problema ka sa radio unit mo tapos you have a Nokia deployment, pasapin mo si Nokia for, did you experience this? Ano naging issue? Ano yung solution? Diba? Or if walang solution, nahanapan ni Nokia na solution yun. Now, on Open RAN, parang, paano ngayon? May problema radio unit, pero if nagturuan yung dalawang vendor kung sino may problema, that's gonna be hard. Hence, you have the standards and tests para walang, para delineated on yung responsibility of various components.
I think this question is to Sir Mon.
Yes po. For Secures ORAN, they are implementing ORAN with security in mind. No? About that said, nasa early stages yung security. And they cannot dictate pa rin for now kasi ano yung security implementation per vendor. But they did recommend various testing procedure and best practices in security. Like, of course, most of this would be embedded Linux or Linux environment. No? You could already see it. So for that, there are standards like CIS benchmarks on how to lock down, let's say, an Ubuntu deployment or a Red Hat deployment, and how do you make it auditable. There are standards for that. I'll be discussing that then again, shameless plug sa 24th. So I have some reference. But overall, yung mga testing for security, no, it is part of ORAN. It's not that detailed as I would have liked it, but there's also a reason for that kasi you're still giving allowance to vendors and manufacturers, no, for their own equipment. And with our current landscape, no, if a vendor gets compromised with a vulnerability na they should have caught early on, medyo babagsak reputation nila, and they don't want that. So they need to lock down yung components nila as needed. Kasi unlike before na end-to-end single vendor proprietary yung system, no? Hindi mo alam kung ano nangyayari sa loob. It's a big black box. But now, each component could be tested individually, security and performance-wise. So, mas, ano siya, I would say mas okay siya kaysa dun sa previous generation. But that said, yet to see pa yung actual deployment for this.
Okay, thank you, Sir Mon. Next question is coming from Henry Laborte. What is the status of Open RAN in our country right now? Are all telco network here are open to operate or willing to share to each other? Maybe to Sir JM.
Yes, I think they're open because if you can remember, if you attended previous symposiums, well attended tayo ng mga MNOs, ng mga telco operators. We have representatives from these operators that are open for Open RAN. And also there is news, if you look in LinkedIn or in the news, one operator did actually have the first setup of the Open RAN. I mean, they have POC, or what we call the proof of concept. So, I mean, if an operator is doing a POC, that entails cost for them. At the same time, hindi naman sila gagastos ng ganun kung hindi sila interesado. So actually, they are very much open, and they have a lot of questions actually, but that's a good thing, right? So yeah. So in summary, yes, they are open, and I hope we can see it in the near future.
Okay, thank you, Sir JM. Next question from Justin Magdadaro. Can a certain operator or telco operating in Open RAN acquire a single vendor equipment to its RU, DU, and CU, but not necessarily lock into that single vendor, so that after a few months or years, the company can decide to change one of its equipment to another vendor?
Actually, I can add one here. Technically, it's Open RAN. I mean, napag-usapan natin kanina, anyone can contribute, and an operator can buy from anyone. Siguro ang magiging restriction na lang dito is legal and finance. Kasi we have POs na syempre nabili mo na order mo na, and meron na kayong kontrata. So hindi ka na pwedeng mag-rescind doon. So yun lang siguro ang nakikita kong maging restriction doon. But technically, you can yung tinatawag nila mix and match in the future.
Okay. Thank you, Sir JM. Coming from Randall. Hi, sir. What will be the connectivity of ORAN to the core and management system? Probably to Sir Mon.
Not familiar with that component much, no? Baka kay Sir JM.
Okay, okay.
This one, I can only speculate kasi nga TIP has an open core group also, right?
Mm,
So we'll see. But for now, hindi ko pa rin din nababasa nga yung
mm,
from Open RAN to open core.
mm,
So how would be the connectivity? But I
Mm.
guess there will be discussion dyan. Hindi na
Mm.
mawawala siguro yun.
mm. But basically, Randall, for this one, if we are implementing ORAN and then connecting it to the core network like the EPC or the NG-RAN, it is the probably S1 or yung NG connection natin. It will be the same as the 3GPP connection. Next is coming from Gerard Tan. In ORAN architecture, how will you ensure network security given its multi-vendor, multi-elements, and multi-brand? What are the needed considerations? Probably for Sir Mon.
Yes, Sir Gerard. So, there are various testing ng components, no, that was required. Although yung, again, yung na-recommend lang dun sa ORAN end-to-end testing document is halos vulnerability scanning lang yung nakita ko eh. I wouldn't be comfortable myself kung yun lang yung gagawin kasi ang daming hindi mako-cover, no? Like API testing, various exploitation na or source code auditing, no? Hindi ni-require yun. But it is responsibility ng vendor to ensure yung software nila has to pass through yung secure software development life cycle, and then yung various components should pass through that. There are recommendations from ORAN like yung mga frameworks like NIST cybersecurity framework. Then if you could implement zero trust, no, since again multi-vendor ka, any data na ipapasa sa iyo ng isang component, you have to validate, no, before you process it. You assume everything is if I would be implementing this, I would assume everything is adversarial. Para trust but verify. Actually, I won't trust. I would verify before I execute. Okay, and then I would increase visibility ng infrastructure, meaning all components would be logging to an SIEM. So all activities, may nag-log in, may nag-modify ng config, may traffic spike, yung mga alerts. You don't want to contain it on that component. Diba? You want to send it out on a log aggregator so that yung mga correlations na parang may nag-alert sa isang component dito tapos biglang nag-spike yung near real-time intelligent controller. So could you actually correlate na mukhang attack ba to or is it a bug na or biglang nag-create ng account bigla sa isang Linux embedded Linux box, no? So all of these activities, yung mga modern Linux systems may way to enable auditing para mag-log siya for that, and ideally you send it out to a central outside the ORAN environment, no, log aggregator na some team, competent team na trained is monitoring it for anomalous behavior ng Open RAN environment. And yun parang at this day and age, it's very hard not to get compromised, no? So kahit sabihin natin gaano ka-secure yan, you're gonna get compromised one way or the other. You got the examples ng mga supply chain attacks, no, like si Kaseya, no, nagkaroon ng ransomware last year. Nahack si Kaseya, dineploy sa mga products nila yung ransomware. Okay, ang daming na-affect. SolarWinds, I'm sure sa mga network guys, no, SolarWinds was hacked. Nag-update yung mga users nila, may kasamang backdoor yung update na signed. Diba? So how ikaw yung RAN operator, how could you prevent that? You're gonna be at the mercy of the vendor's security system. And we do know a lot of big vendors, no? If you want to name them, all of them has been hacked one way or the other. So you need to be able to detect them. So may saying kami dun sa SAN security training namin lagi na prevention is nice, but detection is a must. No? So you need to be able to detect kung may nangyaring kakaiba dun sa network and then figure it out. Okay? Kasi as I've seen now with I do testing, security testing, no, on the other hat, on various banks system. And matatakot ka sa mga API security issues nila. And those issues cannot be tested with vulnerability scanning engine. It has to be someone doing manual manipulation, okay, to do that. And I'm sure you've seen yung mga issues online, no, na pinopost sa social media, nakawan ng ganito, nakawan ng ganyan. Most of them, of course, na social engineer yung user, tapos binigay yung OTP din nila, nagkaroon na account takeover, but there are some that falls into the crack na, oy, mukhang may issue si Bank A, or tsaka si Bank B. But yeah, it does happen. So that's how I would ensure na if I'm gonna deploy Open RAN, I would ensure na okay yung visibility ko. And I have a trained security team that does monitoring and correlation.
Thank you, Sir Mon. Next question from Paolo Jericho. How much do I need to implement Open RAN, and what is the budget range required for startup to start working with Open RAN, including hardware costs?
Wala atang makakasagot yan. Si Sir ba ABC? Sir, pautang naman. Joke lang. Hindi namin masasagot yan. Pero,
Okay.
yeah, siguro kailangan mayamang ka, mga ayalan ka. No, but I think, I don't know, we will see kung gaano to. Pero yun nga, ang ano lang nakita lang namin dito is maraming players ang pwedeng pumasok. But for the cost, I'm not sure.
Yeah,
Yep.
it will depend. Sermon, yes.
Yeah, if I mean, that's telco grade, no? So billion yan ang usap, baka trillion pa nga eh. But if
Sermon,
you're
sorry, hindi ka namin makita.
sorry. Yeah. But if you are referring to let's say mga test lab environment, meron yung kanina yung pinresent ko. Siguro around 20,000 euros, no, with support. You could have your own lab environment na you could develop. But yeah, well, if you're talking actual deployment, well, lupa pala tsaka isang site medyo
ito Richard from Sir Hard. Someone from the industry. So ballpark figure natin dito is 20 million.
10 to 20 million.
Makapag-withdraw nga.
Pesos, rupees.
Yeah, that's only for the access and transport layer.
Ano nga daw to? USD ba to? Euro or what? Peso.
Ano pala to? Peso ba to?
So sometimes, but it's only, ano lang, no? Includes access and transport.
One ORAN site lang pala to.
Tatayo ako ng telco, sir, sa bahay ko na isang set sa bahay. 20 million.
Yeah, and then
bila akong 2 GTR.
And then hindi pa kasama dito yung frequency. Kung ikay bago.
Magbabayad ka pa dyan.
Spectrum
management fee.
And pasahod sa security expert at sa mga RS.
Yun.
Okay.
Pa-budget naman, sir. Pasama kami dyan.
Okay. Next questions coming from Wilbur Lapada. Are there certification bodies acknowledged by the ORAN Alliance that certifies that their equipment software is compliant to the set rules of interoperability? Who are the middleman between operators, and what are the specific duties and responsibilities?
I saw a testing, part ng testing, no? May mga specific test sila bago ka ma-certify na ORAN compliant from the ORAN Alliance, but I haven't encountered a vendor that would do it for you. Maybe si VIAV Solutions, no? Kasi ang dami ng testing, no? I would say na you could reach out to them and figure out how do you make a product ORAN compliant. Kasi daming component niya, no? Lalo na kung may physical layer ka na pati radio, di ba? Yung leakage mo, yung transmission. And yung area pa lang, no? We have one sa EEE na gano'n, yung parang RF room. Parang nasaan nasa set ng movie. Ang laki, temperature control. Tapos feeling ko, maluluto ka ng microwave no, pag pinahirap yun. So, ayoko magtaga. But interesting. But VIAV solution might be a good starting point for that. So but may documentation ORAN, to paano ka mag-comply to ORAN Alliance para parang Wi-Fi Alliance, no, bibigyan ka ng tatak as long as compliant ka dun sa specs nila and na-test nila. So meron din na si ORAN.
Okay. Thank you, Sir Mon. How can we ensure the interoperability of different Open RAN vendor solutions while maintaining the ability to innovate and differentiate? Coming from Brian Mendoza.
Yeah, they would have to comply dun sa mga ano sa ORAN standard documentation. And again, I did an example kanina sa networking, no? Although may standard si IEEE and IETF, ano man daw dun, but
Mhm.
iba pa rin yung magiging implementation eh. And the only way to do that is meron kang full end-to-end ORAN environment. Kasi sisingit mo yung product mo dun. Diba? Tapos titignan mo yung performance and behavior. Aside from security testing pa, kung secure ba tong component na to.
Mhm.
So, yun eh, yun yung
Yep.
medyo dadami yung yun yung ano, I think ito yung drawback ng ORAN. No?
Mhm.
Unlike one vendor solution, sila na yung bahala ng testing nun eh. Now, gusto mo makatipid, kailangan yung documentation nila about the testing is up to par. And we do know, of course, vendors, iba yung sinasabi nila sa datasheet, iba yung sa actual performance. So, you would really still have to test it on test environment na yung load is good as production.
Siguro
Can you-
I would
Yeah.
I
Yes,
would
sir,
I
yeah,
would
yeah.
add, I would add also nakikita ko dito it's an opportunity for collaboration. It's not like bibili ako for this vendor A to this vendor B. It will be a collaboration between integrators and then suppliers. I mean, there would be a synergy of companies na okay, maggugrupo kami, ako magpo-provide nito, ang equipment na to, ako magpo-provide ng integration, ako magpo-provide ng software. They can bundle it and then they can offer it. But iba-iba sila, supplier, but there is collaboration. So, it's an opportunity for business and opportunity for us, ECEs, to have different jobs. I mean, hindi ka lang run optimization, pwede ka rin integrator. And yung mga IT friends natin na ECE can also be in the project. Kasi because it's a software as a service na nandyan na rin. So yeah, that's what I can see from there.
Okay. Thank you, Sir JM and Sir Mon. Are there countries, telecom operators that are already implementing Open RAN already?
Yeah, I think Rakuten, right?
Oh, Rakuten in Japan, yes.
Deutsche Telekom, Vodafone, Airtel, MTN, I guess some of them.
Yeah, so may mga ano na, no? May mga nag-implement na. Next question from Ralph J. Garcia. Is it important to consider all generations, all Gs for Open RAN?
Kasi since Open RAN kasi na papag-usapan for now, and the emerging technology is 5G, kaya lagi siyang na-synergize with 5G. Kumbaga, pag naging mature na ang Open RAN, we are at 5G na. So kaya yun na yung napapag-usapan.
Yes. So the main focus is sa 4G at 5G. But there is a vendor like for example Parallel Wireless. They are focusing also they are looking at the other Gs like 2G and 3G. But for the main other operators, they're mainly looking at the 4G and 5G.
Yep. And
yes, Sir Man.
Issue then of course with maintaining legacy components for supporting old Gs. And security issues then with those older generations medyo malaki, hence firstly attacks sa telco consumer equipment na ida-downgrade nila to 2G. Naka 5G ka na highly secure pero sabihin na signal ko may 2G lang. Which basically is basagin or minsan wala encryption pa so they could intercept yung mga signal doon. So best to maintain na i-decommission mo na yung old. Okay, and move to 4G, 5G.
Yun nga kasi parang ang roadmap na rin kasi ng mga MNOs ngayon is to shut down legacy technology so that ma-reallocate nila yung spectrum to the higher technology. So, yun. So, parang ako as a business point of view, parang hindi na ako masyadong mag-invest into the to the legacy technology.
Okay. Next question from Roed Sar Lopez. Are there any objections towards ORAN implementation Are private companies such as Nokia, Ericsson support this?
Ewan ko kung nag-uusap-usap sila sa loob, nakasila-sila. Pero, what I can say is that Nokia and Ericsson have Open RAN portfolios. No, magugulat ka, di ba? So yung ito yung may mga traditional RAN, pero at the same time nakikisabay sila kasi ayaw nilang maiwan. So in case nga naman na like for example, this Open Asia Open RAN Academy is a collaboration nga. So people we're aiming na ma-adapt natin siya in the near future. So hindi talaga sila magpapaiwan. So I think they're open kasi may mga portfolio sila.
And I think, sir, isa sila sa proponent din mismo ng Open RAN kasi they're losing their market share, diba?
No, yeah, dapat.
Sobrang murang vendors, no? So parang tayo tawag dyan.
Paano tayo babawi?
Kuha tayo sa component na pinakamagaling tayo, tapos, di ba? And if it all goes well, sila yung magli-lead doon sa component na yun. So they could now mix and match based on what's the latest and greatest na state of the art na hindi na end-to-end, na sobrang investment, di ba?
Saka ano rin, iba pa rin yung ano nila, iba pa rin yung feeling ng mga operator sa itong mga batikan. So, yeah.
Yep, parang they want it pero pag tinira ka ng finance, doon na atras ka ng diba? Ultimately, it's a business decision. So kahit na yun yung latest and greatest, pero it doesn't make sense financially, they would go with the lowest bidder, of course.
Yeah, of course. Yeah.
Okay. From Mark Palones, is there certification body that provides certification if the vendor is Open RAN certified already?
Wala pa ata, may ano naman ito sa
certification body, ilalabas siya ni Open Asia Open RAN Academy probably this year. Kakaroon tayo ng mga certifications, no? Yeah. For that one. But probably yung sabi niya implementation more on the technical side.
Siguro yung Oral Alliance sila rin ang mag-framework.
We expect Open RAN to be experienced at the end user level. Mararamdaman nila to, no?
Hindi, pag tayo, yung mga nasa gumagamit, hindi naman natin malalaman kung open nila na o hindi Di ba? Hindi rin naman nila alam kung anong vendor. So, but sana bukas na, no? Meron naman tayong mga taga-vendor, mga taga-operators na kasama dito. Kailan ba, sirs? So,
parang din yan parang IP addressing and routing, diba? Pag yung regular user, on mo lang yung phone mo, basta may Facebook ka, that's it. Yung lang, siguro experience mo would be mas mabilis, mas optimize yung frequency, and then mas mababa siguro at some point, no? Hopefully, if makatipid ka sa Open RAN deployment, bababa din yung cost mo sa calls and tawag. But ngayon, puro only na no? Tapos sa mobile data.
Pero dito kasi may input si Sir Hard Mahal pa raw ang oran.
Yeah.
So, ultimately, at end of the day, ang magdidesisyon pa rin yan is the operator Di ba? Kung i-adapt na nila, kung mag-roll out na sila.
How does this affect the CapEx and OpEx of the telco operators to meet the minimum standards or requirements of ORAN in terms of the hardware or software, etc.? Since we're talking about costs, no? So, paano daw makaka-affect yung CapEx and OpEx?
But I think I can say about the total cost of ownership. You remember, you can highlight yung common tower. Diba? So, the move of the mobile network operators now in the Philippines is towards common tower. So, yung total cost of ownership, ibinigay na nila sa iba. So, as an operator, hindi ko nasakit ng ulo to maintain the towers. So, I can see in Open RAN, since the components will be in the cloud, so you will be having service as software as a service, infrastructure as a service in the cloud. And there are companies that can manage that. So possible din na in the future, itong mga components na to can yung total cost of ownership pwedeng bumaba kasi yung pag-maintain niya would be given to a different vendor, hindi na ng operator. So yeah, so it will be a malaking kabawasan sa expenditure. I think.
Okay, next question is coming from Hope Mamukod. Hi sirs, good morning. Does the ORAN Alliance specification has a 3GPP equivalent document? So Hope, ano to, magkaiba to, no? Kasi ang gagamitin kasi although si ORAN Alliance, kapag wala sa 3GPP specification, gagawa siya ng specification. Like yung mga interfaces na wala sa 3GPP. But if it's within the 3GPP, it will be aligned doon sa 3GPP standard niya. Okay, so ano siya?
Pero for this naman, ang parang magiging mananaig pa rin naman ng 3GPP, di ba? For the technology kasi, di ba? So,
lalo na sa mga interconnections na mga existing like for 5G. Unless doon lang sa mga bagong component like si RAN intelligent controllers.
Controller, yan. So, ORAN Alliance.
Ito kay Sir Benjamin Labadan, Sir JM or Sir Raymond. During the Q&A time of the 8 to 9 webinar, I have asked, ito na ano siya, no? Humabol, Sir Benjamin. I have asked if in the migration from vendor lock-in to interoperability, will all the equipment in the RAN system be totally changed? Or may they make some tweakings on the hardware as well as on the software in order to be ORAN compliant? I have an additional question as regards to that matter. If that is possible, will the innovators include the patent and copyright owners of the original hardware and software in the acknowledgement of their new patents and copyrights of the new ORAN components? Or will the original patent and copyright owners just disregarded by them? Yeah, so sinunod-sunod niya na yun, question.
Paano ba? Ang intindi ko dito is may legacy ka, ay may current na network.
May current siya.
Iti-tweak mo lang siya. So I think hindi.
Ano
Kasi
daw
kailangan
gagawin,
mong, that's a traditional RAN eh. So iba mga protocols doon, iba yung architecture niya. So talagang a major overhaul. Kaya nga medyo yung mga network operators mag-iisip muna, ano ba, itutuloy ba natin to? Kasi hindi siya katulad na currently, na for example, mag-upgrade ako, nandiyan pa rin yung network mo. Mag-tweak ka lang. Hindi. For Open RAN, you have to overhaul. I mean, yung bagong network talaga, magle-layout ka. The towers will be there, pero iba na yung equipment mo i-install. And then, in terms of the patent, I'm not sure. Kasi since open siya, so who owns the patent, right? The specifications will be defined by the ORAN Alliance. So, hindi siya katulad ng Nokia, ng Ericsson, ng Huawei, may kanya-kanyang mga patents yan na tinatago nila sa isa't isa. So it will be open RAN, yun nga, open. So I don't think anyone can own a patent or a copyright for the software.
I think for the patents, sir, pwede. It's kasi different implementation. Technology.
Okay. Okay.
Yung open would be yung interface niya to talk to the other components. So,
but yung sa, okay, sige.
Pag-implement, let's say, meron kang ni real-time integrated controller na FPGA gagamitin mo para efficient, di ba? That's yours. Or ibang technology. Pero it has to talk na standardized across multiple components.
And also for the RIC, di ba? So it's programmable and any vendor can create their own program. So yeah, they have their own. Yeah, tama.
So, kung may mga components ka na hindi mo naman kailangan, ito na yung gusto mo para efficient din, then you could maybe patent some of those implementation. But yeah, yet to see kung paano gagawin yan.
Paano? Oo nga, tama sir. Okay, sir.
Okay, yan. Thank you so much, Sir JM and Sir Raymond. Don't forget to like us on Facebook and watch the recorded session sa aming YouTube channel. So kung gusto niyo mapanood yung mga ibang sessions ni Asia Open RAN Academy, punta lang po kayo sa aming YouTube channel. Meron po tayong YouTube dyan. And then you can just browse and then find the videos na hindi nyo na miss nyo during the discussion.